All right, so here we have a quadratic function for our precalculus problem of the day. So we have f of x equals 6x squared plus 12x. Quadratics make up a big part of a precalculus course. They're used a lot in calculus, algebra, as you probably know. So this is a very important concept. You want to be able to work with quadratics pretty easily. And so we're just going to find a few things about this quadratic and then we're going to graph it. And so we'll start with the vertex. First of all, let's identify kind of the form here. So most textbooks would call this standard form, ax squared plus bx plus c. So in this case, the a would be 6, the b would be 12, and then the c would be 0. And so the vertex is an ordered pair. And so the vertex is wherever, so the shape of a quadratic is like a U, or it could be upside down U. And so the vertex is wherever that parabola changes direction. So either the bottom or the top, depending on which direction it's going. And so it's an ordered pair. So we need to find the x coordinate and we need to find the y coordinate. So the x coordinate is just x equals negative b over 2a. So it's just a simple matter of plugging in this case, 12. So negative b would be negative 12 over 2 times a, which is 6. And we get negative 1. And then to get the y coordinate, if we know an x, we can plug x into the formula and then get the y coordinate. So we need to find f of negative 1. That would give us the y part of the vertex. So 6 times negative 1 squared plus 12 times negative 1. So that would be 6 minus 12, which would be negative 6. So the vertex is negative 1, negative 6. All right, now to find the x-intercept, we set y equal to 0, or we set the function equal to 0. So let's do that. So we're going to solve this equation. And we can factor this. So we can factor out the greatest common factor, which would be 6x. And then what are we left with? We have x plus 2. So, using the zero multiplication property, the zero product property, that's what it's called, zero product property, which says if you have two things multiplied together that equal 0, so a times b equals 0, that means either a equals 0 or b equals 0. And so that's what we have here. So we have a product. We actually have three things if you count the 6. Well, let's just say we have 6x equals 0 and we have x plus 2 equals 0. So either 6x equals 0 or x plus 2 equals 0, in which case we have x equals 0 and we have x equals negative 2. All right, so those are our x-intercepts. Then to get the y-intercept, of course, we just find f of 0. So that would be 6 times 0 squared plus 12 times 0. That would be 0. So that's our y-intercept. And then vertex form. So typically this one is called standard form. Now, the textbook that I use in my pre-calculus class actually calls vertex form standard form. So if you're in that class, you'll be asked to find standard form, but they really mean vertex form. All right, so vertex form looks like a times x minus h squared plus k. And then the ordered pair hk is the vertex. So we already found the vertex, negative 1, negative 6. We just need to plug that in for h and k. A is the same a that we have up here. So we already know that a is 6. And then we're going to have x minus h is negative 1 squared, and then plus k. K is negative 6, so that'd be a minus 6. So this is x, or 6 times x plus 1 squared minus 6. And you should, so you can check this. you should be able to FOIL this x plus 1 squared and then distribute the 6, combine all your like terms, and then you should end up back with this. So these should be the same function. So as long as you do this correctly, this function here, which is the vertex form, should equal this, which is in most textbooks called standard form. But again, I think in the pre-calculus class that I teach, they call this standard form, and then they call this vertex form, or they don't call this vertex form. They don't know. I don't remember if they call it anything, but for sure they call this standard form for some reason. Um, okay, so we got the vertex here. -1, -6. We have the x-intercepts, 0, -2. We got the y-intercept of 0. And then, of course, vertex form, which you don't need to graph for the graph. We really just need these uh, four things, I guess, two x-intercepts. So to graph this, most graphing software, so we're using WebAssign in my class, um, you need to plot the vertex and then you need to plot some other point. It doesn't really matter which point it is. Um, if you're graphing by hand, you might need to do more than that. So let's do a little bit more than that. So we'll start with the vertex. So -1, -6. 1, 2, 3, 4, 5, 6. So -1, -6, there's our vertex. And we actually know this is going to open up. Now, you don't have to know this to graph it because we can just plot the intercepts and get it. But we know this is going to open up because the A is positive. So if A is positive, the graph is going to open up like that. If A is negative, the graph is going to open up like that when we're talking about quadratics. So we got a vertex here. 0, 0. So we need to plot 0, 0 for that. We need to plot -2 for that one. And then, of course, the y-intercept is 0, 0. If an x-intercept is 0, the y-intercept has to be 0. Just the way it is. All right, so we're going to plot 0, 0. And then we're going to plot -2, 0. And then that's it. Sometimes, most of the time, probably, the y-intercept is not the same as one of the x-intercepts. So if the y-intercept is not 0, then you can plot that point as well. So wherever it would fall. But that's all we got. So it's going to look like that. And keep going. And based on section 2.3 or 4, I think 2.4 in the Stewart textbook, transformations. So remember, um, well, if we look at this one, so what are the transformations for this? The -6 moves it down 6, which we have that move down 6. The +1 moves it left 1. We've done that. And then the 6 here does a vertical stretch. So this is skinnier than what you'd expect. So just a standard x squared looks more like that. So the 6 stretches it up. The +1 moves it left, and then the -6 moves it down. So you actually almost could have graphed this based on what we learned a few sections ago. But you do need to be able to find the vertex and find the intercepts and then to be able to graph it. So if you got any questions or comments, leave those. If you have any other problems you want me to do, leave it in the comments or send me an email.